Okay, we're continuing with the Chapter 2 review for Honors Algebra 2 and Regular Algebra 2. And in this case, we're supposed to find the vertex of this absolute value function. And there's a couple ways to do this here. You can take this number, change the sign, and divide it by that number. And so that would look like this. So you get -3. That'll be the first part of the vertex. And the second part of the vertex is always the last number, 8, like that. The other way to get this front number right here is to simply take the contents of the absolute value bars. I'll show you this way of doing it. And 4x plus 12. If you set that equal to 0 and solve, you'll get the value of h, which is the name we give to the first part of the vertex. So you can see we get this number down here by doing that. And once again, the number at the end there will be your k value. Okay, so that does it for problem 23. We found the vertex. It's at -3, 8. Okay, we're supposed to graph these two functions on 24 and 25. You're familiar with the first one as simply a linear equation, y equals mx plus b. So you start with a -1 and put that on the y-axis, and then you count 3 spaces up and 4 over, 3 spaces up and 4 over to count out the slope, and then come down 3 and back 4 to finish it off. So that's that one. Now on number 25 here, we first have to find the vertex. So I'm going to take this x plus 3 that's in the middle there, and I'll set it equal to 0. Solving for x here gives -3, and that'll be the middle value on your t-chart. It's the value of h. And climbing out of the hole, you go -2, -1, and 0. Going deeper in debt here is -4, -5, and -6. Those are some good choices for x, since there's 3 of them on each side of the vertex. Okay, you can look at the n value is plus 0 there, and you know you're going to have a 0 for that. So you can see that our vertex is at -3, 0. Now, if you plug these numbers in, you should get symmetry. I usually do the first one just to check it. So I'm going to do this one here and see if I get the same value when I plug in 0. So first of all, 0 plus 3 is 3. The absolute value is still 3, but then you change the sign and you get -3. And that's this point right here. And then let's try the -6 and see, hopefully, if we get the same value here. So putting in -6, -6 plus 3 is -3. The absolute value is +3, but then this sign changes it back to -3. So sure enough, we get the same answer on both sides. We have this symmetry going on here. Another way to accomplish this here is to take the number on the outside, which is a -1, times the number in front of the x with an absolute value wrapped around it, like this. And that'll give the slope of the right arm. So if you take -1 times the absolute value of 1, you get a slope of -1, and that'll make this thing go down to the right, down to the right, down to the right, like that. And then obviously the other one will go down to the left, down to the left, down to the left. Now if you plug in the rest of the numbers here, you're going to get -1, -2, -3, and there's symmetry here. So the y values spread out symmetrically around that center value. Okay, that does it for 24 and 25.